Guys, have you watched the K-dramas?
Yes, why?
After watching this basketball scene, I started wondering, why do they make almost everything? Are they also after academies?
Maybe they're very scared.
Or maybe it is for the drama? But what if there's another explanation? Could mechanics be the reason behind a successful basketball shoot?
Let's find out.
Basketball is a team sport in which two teams of 5 players, each excluding each substitute, oppose one another on a rectangular court. In basketball, the success of a shoot depends on more than just a player's shooting ability. The principle of mechanics and physics play a crucial role in determining whether the ball successfully enters the basket. Factors such as a force, launch angles, velocity, and projectile motion, all of that influence the accuracy and effectiveness of a shoot. The ball follows a parabolic trajectory determined by its initial velocity and the constant acceleration due to gravity. The motion can be decomposed into horizontal and vertical components by applying the concept of weight and force components. The motion of the ball can be analyzed.
This study aims to provide a complete analysis of the mechanical principle behind a successful basketball shoot. To achieve this, the study combined two fundamental physics concepts. The first is energy conservation analysis, which is used to determine whether the basketball initial kinetic energy is sufficient to overcome gravitational potential energy and reach the height of the hoop. The second is projectile motion analysis, which examines the ball two-dimensional motion after it leaves the player's hand. The analysis helps determine the initial velocity, launch angle, flight path, and time of flight required for the ball to pass through the hoop. Together, this concept helps explain the factors that influence shoot success. The study focused on understanding how physics explains successful basketball shoots. There are two main problems to solve. First, we analyze whether the ball kinetic energy at release is enough to overcome gravity and reach the height of the hoop. Second, we use projectile motion analysis to determine the launch speed and angle needed for the ball to follow the correct parabolic path toward the basket. For a shoot to be successful, both conditions must be met. The ball must have enough energy to reach the hoop and an accurate trajectory to pass through it. This analysis demonstrates how mechanics and physics can be used to explain successful basketball shooting.
Next, I will explain question 1. The question asks, why do skilled basketball players consistently make successful shots into the hoop? In this situation, a basketball with a mass of 0.62 kilograms is thrown from a height of 2.0 meters with an initial speed and 8.5 meters per second. We assume that there is no energy loss due to air resistance. The basketball hoop is located at a height of 3.05 meters. To answer this question, we need to calculate the kinetic energy of the basketball, the potential energy required to reach the hoop, and then compare both values. First, we calculate the kinetic energy of the basketball when it is released. The formula is Ke equal 1 over 2 mv square. Substituting the values, Ke equal 1 over 2 times 0.62 times 8.5 square. The kinetic energy is Ke equal 22.40 joules. Next, we calculate the minimum potential energy needed for the basketball to reach the hoop. The height difference is 1.05 meters. We need to using the formula PE equal mgh. Substituting the values, PE equal 0.62 times 9.81 times 1.05. The potential energy required is PE equal 6.38 joules. Finally, we compare the two values. The kinetic energy is 22.40 joules, while the required potential energy is only 6.38 joules. Since 22.40 joules is greater than 6.38 9.38 joules, the basketball has enough energy to reach the height of the hoop. Therefore, we conclude that the ball has sufficient energy to reach the basket. In real basketball games, skilled players consistently make successful shoots because they release the ball with enough speed and proper technique, allowing the ball to reach the hoop efficiently.
Now, let's look at question number 2. So the basketball player shoots a jump shot releasing the ball at a 50-degree angle from the horizontal, and the ball leaves the player's hand at a horizontal distance of 8 meters from the center of the basketball hoop and a height of 2.1 meters above the floor. The center of the hoop is 3 meters above the floor, so now we need to find the initial speed of the ball. So, for part A, we need to first set up our coordinate system with the origin placed at the ground, directly below the point where the ball is released. From this, we can state that the initial position of the ball is x naught equals to 0, y naught equals to 2.1 meters. The final position, which is where the ball enters the hoop, is x equals to 8 meters, yf equals to 3 meters. From the initial velocity components, the horizontal components, v naught x equals to v naught cos 50 degrees. The vertical component, v naught y equals v naught sine 50 degrees. And since we're ignoring air resistance, the net force is F equals to negative mg, acting downwards. Now for part B, we need to find the time of flight and the initial speed of v naught. So first, in step 1, we need to use the horizontal equation. The horizontal displacement, x, F equals x naught plus v naught cos 50 degrees, and then we need to multiply by t. So we need to substitute known values. 8.0 equals 0 plus v naught cos 50 degrees times t. And then we get t equals 8.0 divided by v naught cos 50 degrees. So for step 2, we need to use the vertical equation. Yf equals to y naught plus v naught times t times sine 50 degrees minus half g and t squared. So we need to substitute our values. 3.0 equals 2.1 plus v naught sine 50 degrees times 8 over v naught cos 50 minus half times 9.8 times over v naught cos 50 squared. So when we simplify this, it becomes 0.9 equals 9.534 minus 758.95 over v naught squared. So we arrived at v naught squared equals 758.95 divided by 8.634, which will then give us the v naught equals to the square root of 87.9, and approximately we will get about 9.38 meters per second. So for the final step, which is step 3, we need to substitute v naught back to find the time of flight. So t equals to 8.0 divided by 9.38 times cos 50 degrees, which is 9.38 times 0.6428. We will then get t equals to 1.33 seconds. So our final answers are the initial speed equals to 9.38 meters and the time of flight t equals to 1.33 seconds. That means the player must release the ball at the speed of 9.38 meters per second, and the ball will take approximately 1.22 seconds to travel through the air before entering the hoop.
Lastly, I would like to conclude our presentation for question 1 based on the principle of energy conservation. The initial kinetic energy at release is 22.40 joules, which is greater than the required potential energy of 6.38 joules. This shows that the player generates enough force to overcome gravity and allow the basketball to reach the hoop successfully. For question 2, the calculated initial speed is 9.38 meters per second with a time of flight of 1.33 seconds. This result proves that the basketball follow a projectile motion in parabolic trajectory and reached the target successfully. This also demonstrates that the correct launch angle and initial velocity are important factors in producing an accurate basketball shoot. In conclusion, this project helped us understand how the principle of energy conservation and projectile motion can be applied in real-life sport. By analyzing the calculation, we can see how force, release angle, and release height work together to improve shooting accuracy and performance. Thank you for your attention.